Today we are going to start radiopharmaceuticals. Radiopharmaceuticals. These types of questions may be asked in their examinations. What are the radiopharmaceuticals or radioactive substances? Radioactive substances means substance which may be able to emit rays or radiations or particles that are called radioactive substance, and that particles or that rays that may be affect to photographic plate, and we can observe their particles on the photographic plate. So elements which are known as radioactive substance, that will be, that you can say that may be the unstable and maybe undergo you can say decomposited by the eliminations of radiations or rays. So the radioactive substance, basically they are, can say, unstable substance which may be able to emit radiations or particles, and that we can obtain on the photographic plate. Okay, for example, uranium series, or means uranium, thorium series, actinium series. So these are the d orbitals and f orbitals. D and f orbitals, you can say, metals, they are come under the radioactive substances. And the radiations which are emitted, or rays that is emitted by the radioactive substances, alpha rays, beta rays, and gamma rays. These three types of rays that can be emitted by the radioactive substances. So that is the meaning here, that we have discussed that radioactive substances, which are the substance which may be emit to the radiations and particles that we can that may be affect to the photographic plate, and that radioactive element that may be eliminate radiations, or can say rays like alpha, beta, gamma rays. And we can say that radioactive substance may be the unstable, and that may be decomposite, that may be able to eliminate radiations. So that is the meaning of the radioactive substances. Next, radioactive substances. Now we are discussing the meaning of pharmaceutical active radioactive substances, or radiopharmaceuticals. So the radiopharmaceuticals are the substances which may be used in the diagnosis and therapeutic intervention, or you can say treatment of disorders or disease. So we had discussed in the previous slide that the meaning of the radiopharmaceuticals. Radiopharmaceuticals are the substance which may emit rays or radiations, alpha beta radiations, and what happen continuously, they will these substances or radioactive substances will emit radiations. So continuously their weight or their mass may be degraded, and they are degrading, decomposing continuously. So they are unstable substances, decomposable substances. Continuously they are decomposed because of emissions of radiations, alpha, beta, and gamma radiations that we have seen. So that types of substances which are important in pharmaceutical field for the treatment of and diagnosis of disease and disorders, we can say them radiopharmaceuticals. So radiopharmaceuticals, they are medicinal formulations which may be used, which should be safe in administrations in human being for diagnosis and treatment of the disorders. And they are unique medicinal formulations that may contain the radioisotopes which may be used for diagnosis and treatment of particular disease or disorder. So we are here discussing in detail about the radiopharmaceuticals, the meaning of the radiopharmaceuticals that we are discussed over here. That radiopharmaceuticals are the substances or radioactive substances which may be used in field of pharmaceutics, that may be used in diagnosis and treatment of disease and disorders, that should be safe to the human being, that may be used for diagnosis and treatment of the disorders. So these are the radiopharmaceuticals, the meaning or definitions that we had discussed. So any nuclide which is not radioactive in nature, regarded as stable, and to be nuclide may possible the appropriate energy, those nuclei which undergo the spontaneous nuclear change so as to attain the stability emitting radiations are called radionuclei and radioisotope. It means radioisotope, radionuclei will emit radiations, so their nucleus is not stable, the nucleus getting changed. Look at here in this picture, that nucleus when emitting the alpha nucleus is the alpha nucleus, then the size, or you can say the chemical nature and property of this nucleus. Now another molecule that is another nucleus that is formed, that nucleus, that nature of nucleus that is changed. Then again the beta radiation if emitted, then another nucleus that is formed that is of different nature. So what happened? They are called as the radioisotope and radionuclides. They have the different you can say properties, shape, size, and everything that is different. The properties are different, and because of the change by the emissions of alpha and beta radiations. Next. Now we had discussed that the radioactive substances may emit radiations, alpha radiations, beta radiations, gamma and X-rays. Okay, gamma radiations, X-ray radiations, somewhere X-ray radiations, but mainly they are gamma radiations. So gamma radiations, they may be converted X-ray radiations. So the alpha radiations, you can say that is helium. Just like helium ions, alpha radiations, they are positive one, positive, you can say charge there. Beta radiation, they have the negative charge on that, and gamma radiation, they does not have any charge. First thing. Second thing, about the penetration, we are discussing here the penetrating power. So the penetrating power, look at here, there the paper here is in the path of radiations. We are putting the paper, plastic, lead, and concrete. So what happened? The alpha radiations may not penetrate to the paper also, because it will be stopped. Paper may stop to the alpha radiations. Beta radiation may be stopped by the plastic, but gamma radiation have the good penetration power. It may be penetrated in all paper and plastic, may be prevented by the lead, by the metals, okay, by the bones. So X-ray, you know, the X-ray, how X-ray work? X-ray may be able to penetrate throughout the body, and you know, only the bones may not be, alpha radiations may not penetrate to the bones. So what happened in the photographic plate, we obtain a image of can say for bones. So where is the bone fracture is there and a breakage is there, we can find it out and we can check it out. So that is the way of the X-ray. I think you might be seen in hospitals and everywhere. So that is the penetration power. So as I can say, gamma radiations have highest penetration power than beta and then alpha. Next. So look at here the alpha beta radiations. That alpha radiations, they have low penetrating power. They are positive in charge. The positive in charge, like I have discussed with you, the helium having can say 2 electrons, and it can be donated. It can be able to can say donate when Helium donate the two electrons. Then what happen? It will be converted into the helium plus 2. Now the helium plus 2, that is called as the just like a alpha particle. It becomes the alpha particle. Okay, so it can be can say it may carry two positive charges. Like helium, there is two positive charge. It is there. Mass of that helium, mass of alpha radiation, that is 4 AMU. This is 4 AMU. Okay, AMU means mass, atomic mass unit. Heavy metals have capacity to emit such types of rays. So what happen? Heavy metals like nickel, platinum, and all, means more than that, like uranium, thorium, and all, they may able to can say donate uh, these alpha radiations, may emit these alpha radiations. Okay, so another, the alpha particles, they have the same energy. Penetrating power of alpha rays are less as compared to the other emissions like beta emissions. Okay, so like radium can donate the helium, means there is alpha particle. Okay, so what happen? It will be converted the radium can be converted into radium. Okay, so that is happening in the alpha particles. Next, beta rays or beta particles. Beta particles, they are basically two types. One is the positrons and negatrons. Okay, positrons, they're positively charged, and negatrons, they are negatively charged. But mainly the beta particles, they are negatively charged, and they having the negative charge on their mass is negligible. Their power of penetrating power is more than the alpha particles, alpha rays. Okay, and but yes, penetration power is less than the gamma radiation that we had discussed previously. So the particles that may be less ionized, less ionization power than the alpha particles, they have the negative charge on that. Now the gamma radiations, they have the highest penetration power than alpha and beta. They can be penetrated throughout, you can say, all types of paper, like plastics, like clothes, and everywhere. Yes, may not be penetrated to metals. Okay, so like bones. Okay, so X-ray, that I have explained with you, that about the X-ray, that is the gamma radiations, just like electromagnetic waves that may be penetrated throughout, means by the body, may be stopped by only bones. So X-ray may be used for detections of, for structural determinations, or you can say study about the bones. So yes, there is no mass on the X-ray and no charge. Yes, we have discussed that helium or alpha radiations, they have the charge, means positive charge, and mass, 4 AMU. Beta radiations, they have no mass but have charge, negative charge. Okay, and but the gamma radiations, they have no charge and no mass. Okay, chargeless. But penetration, thing is that penetration power is very, very high. Okay, so that we have discussed. Yes. Next. So look at here is a comparative study about the alpha, beta, gamma radiations. These are the alpha radiation, beta radiations, and gamma radiations. Okay, that helium nucleus, that is 2 proton and 2 neutron, that is having mass is 4, charge plus 2, and is high speed from the nucleus. Okay, when it is expelled out. Here that in beta radiation, that is mass, there is no mass, but it is it have the electrons negatively charged, so high kinetic energy electrons. Gamma radiation, they have the high frequency electromagnetic radiations, because of mass is 0, charge is 0, but yes, penetration power is high because of high frequency of electromagnetic radiations, alpha radiations having. Here, alpha radiations, they have the low penetrations, and beta radiation, they have moderate penetrations, and gamma radiation have highest penetrations. Why? Because of their slow speed, because of big mass. Mass is high in case of alpha radiation, because of I have discussed with you that the helium. So helium have the 4 AMU, there is mass. So high mass, so may not be penetrate. But here the gamma, the mass is 0 and charge is also 0. Okay. So here, and also that because of mass and there is the proton is there, so it has alpha radiations have high ionization capacity, then beta radiation have low, and gamma radiation have lowest ionization power. So that we have discussed in comparative way about alpha, beta, gamma radiations. That is very important thing. Some other important, you can say, points that is very important that we are going to discuss here over here, that what are isotopes, meaning of isotopes. Okay, so first, what is the nuclide? Nuclide or nucleus, that is every atom has a nucleus, and within the nucleus there is the two things. One is proton, another is neutron. So the mass of nuclei is due to the mass of or weight of proton or mass of neutron, because of mass of electron is very negligible as compared to these particles. Look at here, carbon C6H12, sodium. Okay, sorry, carbon there is 6 and 12, and sodium there is 11 and 23. So they are the nuclei. Now the isotope, what is the isotope? So isotopes are the nuclei with same atomic number but different mass number. Means atomic number is same but mass number is different in isotopes. So they are called as isotopes. Okay. So for example, hydrogen have 3 isotopes because of that H1, 1H1, 1H2, 1H3. So means mass is getting increased. Okay, mass number is increasing here, but atomic number is same. Look at here, atomic number is same here, 1, 1, 1. Okay, so atomic number is same, but mass number is getting changed. Carbon has these number of isotopes. So that is the meaning that isotope means they have the same atomic number, but mass number may differ. So how mass number may change? Mass number may change by changing in number of either number of proton or number of neutron. So mainly the number of neutron gets changed. Okay, so many nuclei, that is number of neutron that is changed here, and the changing in the neutron by only emitting the alpha, beta, gamma radiations. Okay, so isotopes may be stable or unstable, and that is depends on you can say nucleus. So nucleus is unstable if the number of the neutron is less or greater than the number of the protons. So if the nucleus becomes unstable when the number of neutron, means proton and neutron is you can say unequal. So for stability, the nucleus should have same number of proton and neutron. So what happen, that stability of nucleus will increase. Okay, and if the number of proton and neutron is disturbed, then you can say stability of nucleus of any atom, that will be there, disturbed, you can say. Okay, so we have discussed that radioactive substance and radioactive nuclei, what happened, that they are continuously emitting the alpha, beta radiations, alpha, beta, gamma radiations. So what happened, alpha and beta, gamma, alpha radiation that is emitted by the nuclei only, the neutron that is emitted here. So the neutron, number of neutron is changing there. So mass is getting changed, mass is get affected. So what happened, that radioactive substance is unstable, is not stable, as we had discussed. So that is the basic chemistry behind radioactive isotopes or radioactive substances, that we have discussed about the meaning of isotopes and nuclides. So radioactive isotopes that can be injected safely into our body or carry the molecule which deliver the isotopes to the area to be treated or examined. So what do you mean? That yes, there is a two way. that radioactive substances that can be either directly we can say reach into the target site, or maybe some carrier molecule will be required to reach there. Especially radioactive substances we can use mainly in the diagnosis and in the treatment in case of cancer. Tumor cell, what happened? What is the tumor? Tumor is the unwanted growth of the cell, uncontrolled growth of the cell. Okay, so what happened? We need to destroy that cell, and that uncontrolled growth of the cell cancer. So that cell would be the unmature, and then functioning of the cell will not be proper. Okay, so what happened? We have to remove it, and the number of these types of cell is increasing in particular zone, then it may be converted into the tumor. Okay, means number of the cell, the same types of cell, these types of cell, that is non-functioning cell, unwanted or uncontrolled growth cell, you can say, that is collected, that is known as tumor. So tumor we have to be kill, we have to be remove. So what we have to do? We have to use radiopharmaceuticals. So radiopharmaceuticals may kill to that types of cell, but yes, there are the number of our wanted cell, or you can say that important cells are there in our body that should not be affected. So what we have to do in case of anti-cancer treatment, we have to use some carrier molecule. So the carrier molecule helps in the can say penetrations of radiopharmaceuticals. Okay, and radiopharmaceutical may reach into the particular cell, that is, you can say that we want to destroy it. So that is point that we have discussed. Okay, look at here the usage and working, basically that how the you can say radio tracer and radiopharmaceuticals may use in radiopharmaceuticals, or you can say in the field of pharmacy, in medicine. Radio tracer that may be injected into the vein and emit the gamma radiations as it decays, and camera scans there in the radiation area and create an image. So what happened? That just like you can say these types of picture. So this types of system is there. So patients may can say enter in this machine, and there is gamma radiations are there. That gamma radiation this camera can scan it. Okay, so scanning may takes place. Okay, so that is happening, that we can use the gamma radiations in the diagnosis way or in the treatment. So that we have discussed in detail about the radiopharmaceuticals, how they act, how they work, and in detailed way. Now we are going to discuss about another topic or another part, that is radioactive decay. Radioactive decay, that we had discussed, that radioactive substance continuously emit radiations, alpha, beta, gamma radiations. That's why their mass is getting changed, and they can say it is called as decay. It is destroying. So what happened? Say for example, we have can say 100 gram of any substance at a time. Okay, maybe after some time it may be there, the 50 maybe convert into 50 gram, maybe convert into 25 gram, and maybe convert. So finally what happened? It may be nearest to zero. Okay, so what happened? Because of emitting the alpha, beta, gamma radiations, their mass, the amount they are emitting, amount they are, you can say, decaying. So that is called as radioactive decay. Okay, that we will discuss again in the next slide as well. Now the types of radionuclides, natural radionuclides like uranium, like radium. So there are the, you can say, 40 elements or 40 natural radioactive nucleotides are there. They are available in nature. Okay, and some are artificial radioactive substance that can be you can say prepared by human being. So the radioactive, the unit of radio active decay or radioactive, you can say unit of radioactivity. What is the meaning of radioactivity? The activity of a unity of the radioactive material is expressed in terms of the number of spontaneous nuclear transformation taking in a particular time. So what happened means activity of any active radioactive substance, or the quantity of the radioactive substance that is decaying at particular time spontaneously, that is called as radioactivity. Means at fixed time or continuous time, fixed period of time, we can say the radioactive substance that may losing their weight, their quantity. Okay, so that is called as radioactivity. So radioactivity can be the SI unit of radioactivity, can say there is becquerel. Okay, and the becquerel that is reciprocal, or can say 1/2 or second inverse. Okay, becquerel is nothing, is because of its name of the scientist. Then also the Curie, Madame Curie, who discovered the radioactive substance. By the name of Madame Curie, they can say this unit of radioactivity that is given. So the Curie will be, you can say, equal to the 3.7 into 10⁻10 disintegration per second. Means that much of disintegration, that much of particles that may be emitted in per second. So that is the meaning. Ronjan is another unit. Rad is another unit, that is absorbed dose, that is used in radiopharmaceutical dosage form. The rad unit, RAD. RAM and exposure rate constant, RAB, relative biological effectiveness. So these are many, you can say, units of radioactive substance. Okay, so radioactive compounds, that activity of radioactivity can be measured in becquerel, in Curie, C, and but in pharmaceuticals or pharmaceutical dosage form, that radioactivity that is measured in rad, RAM, or RAB. Okay. Next. Now another point here, the safe life. What do you mean the safe life? Shelf life means expiry period. Shelf life of the radiopharmaceuticals means expirations of the radiopharmaceuticals that depends on the physical half-life of the radiopharmaceuticals. Means safe life is depends on the half-life or physical half-life. What is the half-life of the radiopharmaceuticals? Or radiochemical stability, that is you can say, and longer lived radionucleic impurities, that is totally depends on half-life. This is denoted by T half. T half, the time, this means time taken by any radiopharmaceuticals to degrade in its half value or half amount of original weight, you can say. Okay, so for example, 100 gram any you can say pharmaceutical that we have, and that is converted into the 50 gram after the some time, for example 10 days. Okay, so the 10 days, within the 10 days, that 100 gram that is converted to 50 gram, it means 100 is the half-life of that particular radiopharmaceuticals. So it is called as the half-life. Means the 50%, the amount 100% we have, and we have now the 50%, it means 50% get degraded. So that is it's the time taken in degradation of the 50% of the amount original value, that is called as half-life. Okay, and yes, half-life can give us the shelf life, that how much, for how much period of amount we can use the radiopharmaceuticals, that particular drug, how we can use, and what will be the dose frequency. That depends on the half-life of the you can say radiopharmaceuticals. Okay, so that is the meaning of shelf life. So last one, that half-life, you can say half-life. What do you mean the half-life? The time in which the radiopharmaceuticals radioactivity decreased to its one half of its original value, that I have discussed with you. That is the half-life. Okay, this is the equations, mathematical equations. N is equal to n0. You can say n0 n to power minus t. Okay, so that is, and this is the half-life. That is finally we can say that is t half is equal to 0.693 divided by frequency, that is the lambda. Okay, this wavelength, wavelength of radiations. So this is the way we can determine by this, by the half-life. Okay, so this is physical half-life, which physically means physically drug, how much drug may be effective, and the physical value means amount of the radiopharmaceutical that may be active, that is come under the physical radio, the half-life. Okay, the formula is there that we have discussed already. Biological half-life, effective half-life. Okay, so half-life measurement, how we can measure the half-life? By using an instrument that is called as Zinger-Muller counter chamber. Zinger-Muller counter chamber, that is used for determination of half-life of any radiopharmaceuticals. Okay.